the leading United Nations platform on artificial intelligence. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with over 50 UN agencies, and co-convened with Switzerland. The mission of AI for Good is to unlock AI's potential to serve humanity. As a multi-stakeholder platform, AI for Good advances solutions, standards, and skills. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging session. Boost your AI skills and elevate your career with the AI for Good Discovery Badge. Receive verified digital credentials that recognize your engagement in cutting-edge sessions, exploring how AI is being used to tackle global challenges. To see if a session is eligible, look for the blue badge banner on the right side of the video interface that activates at the end of each live session. Share your badge on LinkedIn and across your professional profiles, and check the AI for Good Events webpage for upcoming eligible online sessions. Discovery Badge sessions are part of the AI Skills Coalition, ITU's global initiative to strengthen credible AI learning pathways and expand access to high-quality, trustworthy AI knowledge worldwide. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello and welcome all to today's workshop on launch of 2026 ITU GeoAI Challenge, reaching new heights with geospatial foundation models embeddings. So I'm Maria Brovelli, you know probably me very well, from the Politecnico di Milano, and you know me because I'm the creator, together with Andrea Manara and Rohini Swamitam, of the GeoAI webinar series at the AI for Good. And it is my real pleasure to introduce a new episode in the GeoAI Discovery series. I want to remind you that we launched this series at the beginning of 2022, and we have been organizing now around 40 episodes, webinars, hands-on workshops, along with several GeoAI competitions. And today we are here exactly for GeoAI competition. So we have to, if we want to remind what we are doing in this long path, we can say that the current focus of the series now is on geospatial large language models. And we are organizing workshops focused on building up practical skills in applying AI to geospatial data. If you missed some episode of the GI Discovery series, don't worry. You can watch the recordings of these events on YouTube or on the neural network to which you are connected right now. I'm the moderator of today, and as already said, we will introduce this new challenge. This is a challenge proposed by the International Telecommunication Union together with other partners, and we are inviting students and professionals worldwide to tackle real-world geospatial problems using artificial intelligence to support advanced solutions to solve global challenges. This is what we want to do in general. And the session of today introduces the challenge problem statement, reaching new heights with geospatial foundation model embeddings, which was developed in cooperation with the European Space Agency, specifically the PhilAB challenges group, the KTH Royal Institute of Technology, the Politecnico di Milano with a small help, and the group on Earth observation, GEO. This project represents an important first step toward building a global open dataset of digital surface models, digital terrain models, and ground cover categories derived from open satellite imagery. Participants will train models on selected regions and assess their ability to generalize across diverse geographical areas. Such datasets enable a wide range of SDG relevant applications. So you will enjoy participating in this challenge. You can be also the winner, so you will enjoy also the award. But the second award is that you are developing something which is really relevant for the SDGs application. For the ITU, global geospatial datasets are essential to improve the accuracy of the ITU-R radio wave propagation prediction methods, which support spectrum sharing studies, radio interference assessment, and coverage estimation for point-to-area services such as mobile and broadcasting systems. The webinar will present the challenge objective, dataset, and the platform, best practice, and conclude with question and answers. Participants will explore how embeddings from the state-of-art geospatial foundation model can leverage for multitask learning, including land cover segmentation and height estimation. The webinar will present the challenge objective, dataset, and platform. And now, without spending other time in the introduction, I want to introduce the speakers of today. Please, I ask you to appear during my presentation. So the first speaker is Andrea Manara. Andrea is a senior system analyst in the ITU radio communication sector, and this is also the ITU focal point for geospatial information management and a member of the steering committee of the UN Geospatial Network. So good day, Andrea, and welcome.
Hello, Maria. Thank you very much.
I will introduce also the other speakers now, and I will call you again on the floor because you are the first speaker. So the second speaker will be Dennis Albrecht. Dennis is a senior management consultant at Nova Space with 6 years experience in high tech and aerospace. He manages ESAFI Lab challenges, coordinating an international consortium focused on innovation and Earth observation, and is committed to advancing political sovereignty and societal progress through cutting-edge technological implementation. So welcome also to you, Dennis, and you will be the second speaker of today.
Thank you very much. Thank you, Maria.
Third speaker of today is Andrea Rascetti. Andrea Rascetti is a research scientist in urban planning and environment at the KTH Royal Institute of Technology, Stockholm, Sweden. His expertise is very wide, spans geomatics, remote sensing, photogrammetry, SAR, radargrammetry, and computer vision with strong interdisciplinary experience. Welcome also to you, Andrea.
Thank you, Maria. And hi, everyone.
Hello. Valerio Marsocci is the fourth speaker. He's an internal research fellow at the ESAFI Lab working on geospatial foundation models with a focus on benchmarking them for real-world application. He received a PhD in data science from Sapienza University of Rome. I forgot to say that also Andrea Nascetti is coming from Sapienza University of Rome. Then Valerio held postdoctoral positions at CNAM in France and TU Leuven in Belgium. So welcome and good day, Valerio, as well.
Hi, everyone. Thanks, Maria.
Okay, and then the last speaker of today, you see we have a very rich panel today, is Albert Fernandez. He is a full stack developer at EarthPulse with expertise in artificial intelligence and end-to-end software development. He builds scalable, reliable products from complex data. It contributes to the ESA Philab challenges and holds degree in AI and information engineering from UNIR and UPC, Spain. So welcome, Albert, as well. And thank you to everyone for being here. And then at this point, I will give the floor to Andrea.
I thank you very much, Maria, and good afternoon, all. So I will share my screen. Um, so it's really a real pleasure for me to be here for introducing this 2026 challenge. Also because it deals with a topic which is very relevant for the ITU and in particular for the radio communication sector of the ITU. And I thanks myself also all of the partners in this endeavor. So if you have been following the GeoAI webinar series, you may know that we are running this competition since 2022. And this competition is meant to solve real-world geospatial problems by applying artificial intelligence, machine learning to advance the sustainable development goals. What is important is that the ITU GeoAI challenge is fully open and inclusive. Anyone can participate. Students, professionals, researchers from anywhere in the world. And all solutions must be based on open source tools and open data, ensuring equal access to everyone. This openness is essential to support innovation that really serves the UN SDGs. So just to why you should participate, because these competitions are a platform to gain hands-on experience related to GeoAI. So you will have the opportunity to provide inputs and shape the technologies related to GeoAI. It's also very good to network with peers and experts, and then getting global recognition in forms of prize certificates, and also to the possibility to present your innovative solution in one of the GeoAI webinars. And for partners, the benefits are also several. Find innovative solutions to your GeoAI use case, find global talent and visibility throughout the year. So just I would like to introduce this business case under the point of view of the ITU, and then later speakers will really dig in all of the GeoAI technicalities. So the ITU mission, in particular of the radio communication sector, is to ensure the rational, equitable, efficient, and economical use of the radio frequency spectrum by all radio communication services. So we are heavily involved with doing radio communication service planning for determination of the coverage, interference analysis, and for international coordination. This is achieved by the usage of ITUR propagation models, which depends on geospatial data. In particular, what is interesting for this challenge are the terrain height and the surface feature. And I'm making here a snapshot of simulation of a DVB-T station. We have also an ITUR resolution for a worldwide database of terrain height and surface feature. This underscores the fact that is really very much relevant for achieving our goals. So how do we use in ITU global DTM DSM? So we have the ITUR P-series recommendations, and I make here some example of recommendations, which are international agreed radio wave propagation models, which are used by regulators, operators to access coverage, interference, and spectrum compatibility for terrestrial and satellite systems. So this table is providing a list of those recommendations which would benefit for having higher, better resolution datasets. In particular, we have no global DSM, and for some recommendations, we use 30-meter DTM. So this is my last slides, only to put this into a biggest context. So I would say that accurate propagation prediction methods using high-resolution terrain and surface data improve the possibility of spectrum sharing and its efficient use, and thus they directly support the fundamental objectives of the ITU radio regulations to ensure the rational, equitable, efficient, economical usage of the radio frequency spectrum. So for 120 years, the ITU radio regulations, which are embedded in national legislation worldwide, have enabled global radio communication. This challenge is an opportunity for everyone to help shaping the next generation of tools, of technical tools that will keep the radio regulation effective in an era of unprecedented demand for spectrum. So with this, I end my presentation, and I give back the floor to Maria.
Thank you, Andrea. So it's very important to underline that we have organized together many challenges in the last years, but these challenges also, they were important for everyone, but this challenge is also important for ITU. So stressing this fact to all participants, please try to help ITU with the best model that you can provide. And thank you, Andrea, for introducing the challenge from the point of view of ITU. I want to hear also something from Dennis, because ESA is also organizing challenges in general. PhilLab is organizing challenges. So if you can tell us something about that before entering in the specificity of the challenge of today.
Yes, absolutely. Thank you very much, Maria. And also from my side, again, a very warm welcome to everybody who joins us today. I hope that, of course, by now some participants may recognize me from previous webinars. My name is Dennis Albrecht, and I'm part of the organizing team behind the ESA PhilLab Challenges. As you may know, the ESA PhilLab is the European Space Agency's innovation lab for anything related to Earth observation. And with the ESA PhilLab challenges, we aim to strengthen the synergy, not only between AI, transformative innovation as a whole, and Earth observation through public challenges where we want to target the entire EO and AI community. For this, we have 4 goals that we want to achieve with our challenges. We, of course, want to organize these public challenges on a global scale. We're very happy to announce that this challenge will be the 12th challenge that we implement as part of the PhilLab challenges. We're also very happy to implement this first challenge together with the International Telecommunication Union and AI for Good and be part of this GeoAI framework. The second goal that we want to achieve is to build a global AI and EO community, so bringing the communities closer together. For this, we have in the past attracted hundreds of participants from around the world. And of course, we're excited for our new participants for this GeoAI challenge. The third goal that we want to achieve is to provide world-class curated data and tools with our partners. So also for this challenge, I can already spoiler a little bit our partners, not just from ITU and AI for Good, but especially also from the KTH Royal Institute and the Geo Group will provide our participants a world-class data set to tackle this challenge. And then lastly, of course, we also want to help you thrive with your skills and offer you some visibility. So we really want to stress it's not just about the cash price and the action of the moment. It's really just to gaining also a visibility within the community to gain the opportunity to also present your solutions on a global scale in front of expert audiences. And of course, we are not all that have organized this challenge. I would like to quickly give a shout out also to the rest of the team here. You only see some of the team behind this challenge, despite some people that you have already seen in our webinar today. There are countless other people behind the scenes who help make these challenges a success. And we're really looking forward for the next few weeks and see your solutions.
Thank you. Thank you, Dennis. Thank you. And I believe that now we can start speaking about the challenge of today, because the attendees and the registered people, we had 380 registered people to this webinar, and they wanted to have more details about this challenge. And so who better than Andrea and Valerio for presenting the challenge. So Andrea, please start saying something to our attendees in such a way that they can discover if they will be able of solving this problem or not. Okay, so Andrea, you will introduce the challenge, and then Valerio will enter into some details about the challenge. So the floor is yours.
Yeah, thank you, Maria. Can you see my screen in 1 sec?
We can. Before there was the slide, now there is the C.
Yes, now the slide should be back.
The slide again, yes. The C was better, but the slide is fine.
Yes, perfect. So let me try to introduce the challenge, the dataset that we are going to use for this challenge, and what are the tasks that we are targeting for this challenge. So you already introduced the name of the challenge. So it's called Reaching New Heights with Geospatial Foundation Model Embeddings. So as the title suggests, the challenge will use cutting-edge geospatial foundation model embeddings that are already pre-computed and available in the dataset. And we are using 4 of different models for the challenge. So two of them are pixel-based embedding from Alpha Earth and Tessera, and then we have also patch-based embedding from other two foundation models that are called TerraMine and Tor. You will find all the references about these models in the details of the challenge. The challenge was to target a estimation of normalized digital surface model, so the difference between a TSM and DTM model, and at the same time also understand the land cover of that area. And this is relevant, as already was mentioned by Andrea, for ITU, but in general, it's relevant for different sustainable development goals, as this slide remember us. We will train and evaluate model starting from the embeddings in different regions, and we will have to test it in other region as an independent test set. Let me try to give you some reason to join the challenge more than the scientific interest and curiosity. There are also some prizes here. So as you can see, there are 3 different prizes that you can win. So you see we have a first prize, second prize, and third prize that you can win for the best and open solution. And you will find all the details also of the prizes in the description of the challenge. So now the objective is to experiment different ways of how we can merge these 4 different geospatial foundation models for this task of estimating the heights of building and vegetation, plus understanding the land cover, so segment building, vegetation, and water in one area. So basically, we developed the idea of this challenge to experiment feature fusion and multitask modeling using these embeddings coming from different models. And these are the models that I already mentioned, and now we'll go to show you some more details about how we prepare the reference labels for this challenge. So it's not a standard land cover maps, as maybe some of you have already experimented or are familiar with. It's so for these 4 categories that we are mentioning here, we have water, vegetation, and buildings, and the relative height above ground, so the NDSM. But instead of giving like a categorical class for each of these land cover classes, we are estimating the fraction of the class over the resolution cells. So you can see in this schema here, in each pixel, that is, in this case, would be a 10 meter by 10 meter pixel that is matching the Sentinel-1 and Sentinel-2 resolution. You have to estimate the fraction of building, the fraction of vegetation, and the fraction of water that is within that resolution cell. This is more similar to what the satellite is sensing for that specific cell. And we want to use this also to investigate if this can help in having more robust model, especially on the edge of building or on the intersection of building vegetation and water, where these spectral signatures are mixed in the original data, and how the embedding can catch this representation of mixed pixel. So the reference data, Valeria will give you more information about how we split it by training and test set. But basically, we have 4 different bands for the TIFF file that we provide as a reference. In the first band, we have the percentage of pixel for that area. Then we have the second band, that is the percentage of vegetation. Third band is the percentage of water. And the fourth band is the normalized DSM, or relative height above ground. And that's how we prepare the different the labels. And basically, we are targeting 4 regression tasks to regress the percentage of the land covers plus the height above ground. This is an example of the data. So as I mentioned, these are coming from very high resolution LiDAR data. So we have very high details at half-meter resolution for most of the patches that we use. And this is an example of a very high resolution image where we have the corresponding buildings and trees and background class. Here, background means all the terrain feature that are not building or vegetation above 1 meter height and no water. And as you can see, also we have the normalized DSMs containing the height information of that feature above the ground. As you can see, this is a standard RGB visualization of the tree land cover classes. And if you look, now it's a bit small, but if you look close to the building, you can see that there are some mixed color. That means that the pixel have a mixed composition between vegetation, buildings, and water. These are an example of the input data that you will use in this challenge. So these are the 4 different geospatial foundation model that we select. And so the first 2 are pixel level embeddings produced by the Google Alpha Earth embeddings and the Tessera embeddings coming from the Cambridge model. And the first one have 64 bands. Tessera embedding has 128 bands for each patch. The patch are 256 by 256 in dimension. And we also have the 2 corresponding patch level embeddings for S1, so Sentinel-1 SAR data and Sentinel-2 multispectral data for the 2 models that are Terramine and Tor. As you can see here, the spatial resolution of this patch level embedding is less than the one at the pixel level, but they contain more bands encoding all the spatial also information in these 768 bands. And now I will leave the floor to Valerio that will introduce you the split of the dataset and the baseline that we prepare for you.
Yeah, hi everyone. Thanks a lot. I will share my screen once, Andreas. Yes. Okay, so you should be able to see my screen.
Yes.
But basically, I will go more into details about how we split the data and also some practical info about what you should do and what you shouldn't do with this data. So basically, as you can see in the slide, we have the 4 models that in the training data, we have 2024 images, or better, not images, but embeddings, sets of embeddings, in the sense that, as we mentioned already, we have 4 different models to our pixel level and to our patch level models, embeddings, and but for the while for the pixel level, so Alpha Earth and Tessera, we just have one directory, because in this directory you can see that the representation, so the embeddings are already considering both Sentinel-1 and Sentinel-2. In the Terramine and Tor, so the patch level embeddings, you will find different path, one for the Sentinel-1 and one for the Sentinel-2. As you can see in this slide, you can see that again, 2024 files per each directory, even for the labels, but the shape is very different, and Andrea just showed us this. So basically, we have higher spatial resolution for Alpha Earth and Tessera, but we have lower resolution spectral-wise, while for the other one, so basically for Tor and Terramine, we have a way higher spectral resolution. And this is also very related to the size of the dataset themselves. So basically, the Tessera one is kind of big, so it's like 70 gigabytes. Yeah, Alpha Earth is kind of the half, and this is also in line with the bands dimension. As you can see, there are 128 bands for Tessera and 64 for Alpha Earth, while the other models, while having a lot of bands, are very small, again, in spatial resolution, just occupying fewer space, so just almost 2 gigabytes per each of this path. And what is very interesting, and I will show you later, is that with all of these models, with the baseline, we have some unimodal baselines, but we want really to see how you can combine this information, trying to have also lightweighted solution, but not just solution that can use Tessera embeddings, for example, that are the biggest. And in addition to this, in the repository that later Albert will show you, you will also find a catalog, a Parquet file in which you will just have a list of all the files. About the final metric, so the score of, as Andrea told you, there are basically 4 bands in our labels. The 3 are about again, buildings, trees, and water. So the percentage of presence or absence, let's say, of this class, the percentage of presence of this class in that pixel. And then we have the fourth one, that is DSM, a normalized DSM, in which we have basically the height in that point, in that pixel. To have a final, just one final score, we basically combine 5 different scores. The first 3 are about mean intersection over union. So easily we just have 3 mean intersection over union that can go from 0 to 1. But then on the fourth band, so on the band about normalized the DSM, we can compute 2 different RMSE. So basically we compute the height, not just the absolute value of the height, but one part is about the height of the buildings and one other is about the height of the vegetation. So basically 2 different RMSE buildings and RMSE vegetation. As you can imagine, in this case, this is not going from 0 to 1, but it is going from, 0 would be the perfect prediction. So basically what we did is just that we normalized it by some values that we know that are the highest value that you can reach, and then we subtracted this value to 1, so that we have also, in the case of RMSE, we can get back to a score that can go from 0 to 1, even more than 1, of course, in this case. But let's say from 0, then the higher the better. At that point, that we have 5 scores that all of them can go to 0, to the higher the better, up to 1 for the first 3 of them. We just have a weighted mean of these 5 metrics based on what we want to give more importance. So in our case, it was more important to give relevance to the buildings and then to the height estimation more than the segmentation itself. Just to make it sure that you understand this, as you see, we have 4 bands, but we have 5 scores. This is because the last band, so the band about the normalized DSM, we computed 2 RMSE. How do we compute this? Basically, we just take the pixel based on the ground truth, so not on the predicted pixel. So about the ground truth pixel, the ground truth class of that pixel, if that ground truth pixel is a building, on that pixel we compute the RMSE building. If that pixel, again in the ground truth, is a vegetation one, we compute the RMSE about vegetation. Then finally, just to tell you about the test set. Okay, we have 2024 patches for the train set. For the test set, we have 946. That's okay, slightly small. And we expect for each submission to have all the prediction for all the 946 in dot and NumPy array. Why we're specifying that we are expecting all of these 946 patches? Because basically we will have 2 scores, one public score and one private score. The public score is the one that you will see on the leaderboard, and is the one that will be computed on a subset of this test set that we're not telling you. So we want you to, that your model can really generalize also, not just across region and dates, but really also across something that you don't know. So let's say this out of domain generalization that should work independing from different location, different times. But then we need still, again, all of your submissions, so the 946 patches, because then we have also to compute the private score that we will use just for the final ranking. Yeah, other than that, as I already was telling you, we also have a baseline that you will see, okay, here in this GitHub, but you will see also Albert will show you that in the notebook, in the dataset, on the EOTDL platform, there will be a notebook, and in this notebook there will be again the link to this GitHub repository, so you can see this kind of easily, and you will see that we have 2 different baselines. One baseline that is for the pixel level embeddings, and one that is for the patch level embeddings. Just to give you one more minute of details about the repository, you will see that all of the repository is already well documented, and you will see that we already tried to push a little some tweaks to boost performances. For example, we are using a loss that is putting together 4 different loss terms, and this is already working kind of well. Again, but this is just unimodal, and you will find other details about how this repository is structured, how to set up, and we have some model architecture, and as we told you, one for the pixel level embedding, so a sort of unit, and one for, let's say, the patch level embedding that is more just a decoder. We have also some command line and so on. Something that just I want to mention to you before leaving the floor to Albert is that as we already also wrote in the website, we are expecting, of course, the best model, and this is the winner, but we're also expecting innovative solution, because in the case of innovative solution, we can really consider to have a research paper with us to document the results and also to explain your solution, but also we can consider to invite you in the field lab to spend some time here, or just to have a collaboration based on how innovative is your solution. I'm suggesting this also because maybe, okay, you cannot really download or deal with 70 gigabytes of Tessera or 30 gigabytes of Alphard, but could be also very, very cool if you can just have a very cool solution, really competing with the others, just using the lightweight embeddings of the patch level models like Terramind and Tor. So this is just some inspiration, and yeah, thanks a lot for your attention, and I give the floor back to Maria. Thanks.
Yeah, thank you. Thank you, Andrea and Valerio. I have a very quick question to Andrea and Valerio before disappearing now. So, besides the solution, should they provide also some documentation about what are they doing, or are you not expecting to have documentation?
We are expecting the
We're not.
A
Yeah, please go on.
report about what they did.
Yes, a short report, but it's not part of the evaluation. The evaluation is based on the ranking. The report is kind of mandatory to illustrate, and the code also is mandatory to report how they develop the model.
Okay, so it's not only the solution, but the code has to be submitted, and a short report, let us say 3 pages, something like that, where so maximum 3 pages, where they illustrate what they did.
What they did, yes. That's
Yeah,
all
of
these
course.
are specified in the description of the challenge in the web.
Yeah. Of course, to submit your solution, you just need the NumPy files. But then we will ask you in any case the code to double check it, and also a report if we like your solution is even more encouraged to have this report. But yeah, the solution is the evaluation is just based on the NumPy files, just to be very, very clear. But also now Albert will show you how to submit a solution, so it will be even easier to understand what you need and what.
Okay, so let's go to the last part. Now everyone understood what you have to do, and Albert finally will show us the platform where you can submit your solution.
Can you see my screen?
We don't. You are not sharing. Try again. Yes, now you are sharing.
Okay. Yeah, thank you. My name is Albert. I'm working from Earthpools. I'm going to show you the both platforms that you need to interact with the data. First of all, EOTDL to get the data to your machine, and then the platform of the challenge itself to do it a proper submission. First of all, you need to go here to the embeddings to heights, and you need to install the EOTDL library. Okay, I'm going to show you a quick example. Okay, and basically you need to add different arguments in order to download in your machine the dataset. For example, first of all, you need to log in to the platform. Okay, I'm already logged. And then you add the dataset command. Okay, and first of all, you need to indicate the place that you want the dataset, the version of the dataset. We start with version 1, and the assets. Okay, for example, we need that one, the current one, and let me show you. Okay, if you put it the flag A, you download all the assets. Okay, and yeah, that's it. It's the way to proceed in order to make the dataset in your machine. And then if we jump to the platform, this is the challenge. And in these sections, you have all the information regarding the challenge, the rules, prices, data. And to do it, a proper submission, first of all, you need to log in the platform, join. We need to join an existing team or create a new team, for example. And once we create a team, sorry. One second. Yeah. I'm gonna create the team. Yeah, the platform allows us to do a submission. Okay. I will do a submission in order to show you how can we proceed. I put a submission with no correct values, just dummy data. And the process, you will see that the scoring tool is evaluating your results in the background. Okay, it takes 1 or 2 minutes, probably less. And yeah, at the end, you will see the leaderboard, all your results scored in a public way. Okay, and when the challenge closes, it shows or appears the private site, as Valerio said. Okay, when the scoring tool is finished, and you will see each result, each score here, and you appears in the leaderboard. Based on your results, you will be ranked. Okay, it's done. There is an option, a forum, that I will invite you to put it some comments, concerns, doubts, or basically share your experience with the challenge. And yeah, that's it. For any topics, any questions, you can put it here, and that's it. I'll bring to you, Maria. Thank you.
Thank you so much, Albert. Thank you. So now no more excuse. You can start working and submitting your solution. There are some questions. One question that comes to my mind is if the participation is individual or also a team of people can participate. Who wants to answer? Probably you, Dennis, want? Yeah, given your experience with challenges.
Yes, thank you very much, Maria, and also thank you for the community for these questions. That's, of course, a very important one. With the PhilLab challenges and, of course, also with AI for Good, we want to really foster a team-based approach. So we would like to encourage you to join teams. We currently allow teams of up to 5 people to actively participate in these challenges. And anything that you submit, you will also submit as a team. Per team, you will have one point of contact. This is like your team leader, who, in case of any conversation that would be happening with the team, would be our main point of contact.
Okay, but for instance, what happens if in a university or in a class, suppose that different students want to participate and they organized in small teams, and in one class there are 3 teams of students. What happens?
So if you check the rules page of our platform, you also see a little bit more explanation regarding these instances. So usually we are a little bit more strict when people come from the same entity. Let's say, for example, you come from a same background in terms of a corporation, for example, or more a commercial background, then we really want to encourage only to sign up as one team. If, for example, a case like the one that you just described, Maria, where you have a very big class, a very big university class, in this case, we can make some exceptions, and we would also accept several teams from a university class. In this case, however, it is very important that the teams work autonomously within themselves. So for example, if there is a class and you have in the end like 3 teams of 5 people working each, it must be important that the teams work individually and they don't share anything in between. Of course, we cannot check everything, but it is also important that we will ask the participants to submit their code and their approach at the end of the challenge. So we will ask you how you tackled this challenge, and if we have any doubts or have any questions about it, we might get back to you. So
considering what you are saying, I imagine that one person cannot participate to more teams. So I cannot be a member of 2 different teams. I have to choose which team I want to belong to, correct?
Exactly.
Correct.
So only
Perfect.
one individual per team. Yes.
Perfect. So it means that there is the responsible of the team, but we want to have provided also the list of the participants of the team in such a way to check if there are not overlap. And if there are overlap, what we do?
Well, let's hope that it doesn't happen. But in this case, we would have to disqualify the teams, or at least take away some points from the final score. So I really want to encourage everybody participating again. Please read the rules page and approach it with some seriousness. We're very excited for a lot of great solutions. And of course, the more teams, the more individual teams, and the more individual approaches per team, the better. So we really want to encourage you there to respect the rules.
Thank you. That makes sense. And thank you also because we are taking this challenge very seriously, and we are expecting also the participants to approach in the same way. Yeah, thank you. And then a second question is related to, so Bruno is asking, is there any criteria or constraints for the solution? Like, for example, only use open source framework. And Andrea, probably you can answer as I see you here.
So yes, I think if this means, so the code, you have to share an open source solution of the code that you develop for the model and for the solution of the challenge. And this might be related to the different licenses of the packages that you use in this in your code. If it can be like replicated, it should be fine. So it could be like an open source license for non-commercial application. That's fine for us. So it should not be completely open. So you can use packages with licenses that are a bit more restrictive, but we have to be able to reproduce your code. So you cannot use a proprietary software that we cannot test. I hope I replied to the question.
Yeah, no, it is clear. So they have to provide the code. My further question is, will be the code made open and available for everyone at the end of the challenge? So meaning we have the 3 winners or also 100 solutions. Can we provide the code to everyone if they want? I imagine that the most interesting will be the winning solutions, not the last one in the ranking. but I believe that it makes sense to provide them as open solution. And if they are open solution, we need to ask also about which is the license for the open code that will be made available. And so somewhere the participant have also to specify which is the license of the code.
Yeah,
Does it make sense?
Yeah, it does. I think they will share the code with the appropriate license that we can then reshare. But it should be open enough to us for testing and reshare it. So it cannot be a restrictive license. Otherwise, we cannot evaluate it and
Yes, no, it
reshare
cannot be
Yeah.
evaluated, but you can imagine that it can be just made available to the commission or can be open to everyone. And the idea is that the solution in this case will be open to everyone with the license decided by the proposers. Yeah. Okay. Thank you, Andrea. And I believe I have another question for Dennis. So I'm calling again Dennis on the stage. And Dennis, here there is a complaint because the link points to a challenge of 2023, but I believe this is just because it was published. As you can imagine, we finished just a few minutes ago.
Yes, so sorry about that. We will, of course, update the link. Right now it is leading to an old challenge. We will be updating the link right after. And this webinar, maybe to also highlight it again, is really to kick off this new challenge. So we just opened on the PhilLab Challenges, the platform page. So you can start registering and interacting with the challenge now. But of course, we will also send around a little bit more information today after this webinar. So please check the social media channels, newsletters, and so on. And you will get the updated links, of course. If you want to, Maria, I can also quickly follow up on the previous question, just a few less words. So we would like to highlight also from ESA PhilLab side, of course, the ownership of anything that you produce during the challenge stays with the producers, but we really want to highlight that we want to push for open source approaches, for a community approach. So we really want to encourage everybody to foster this more open source approach and share the full availability after.
Okay, thank you. Now, and I believe that is perfectly in line with what we are doing also as AI for Good. So it was a bit strange to have a closed software with respect to this kind of solution, also because I really believe that it can be useful for everyone besides ITU, but it is of general utility, this kind of product in the end. Yeah, and I believe that we have no more questions. But at this point, if there are no more questions, people are starting thinking about that. There were many people connected. I told you before, 380 people registered to this event. And I see that there is one more question. That is very interesting, and I don't have the answer. So I don't know, Dennis, probably again, it's you. So I want to ask you, so there is Bruno asking if there are some computation resources for the participants, like for instance, if there is a possibility to access some GPU server and so on. That is very relevant specifically for those who don't have these resources.
So I'm very happy to say that from the ESA Lab, we have also talked with the team at the Earth Observation Training Data Lab, the EOTDL, where we host the data sets, and we were able to reserve some slots for cloud-based GPU access. These are, however, limited in number. So on the rules page and on the data page of the platform, you will find a bit more information about this. If you require access to one of these GPU servers, then please write us a message, and we will try to get back to you as soon as possible to give you access. Again, I would like to highlight that the access to these are limited. So please also consider that maybe there are some others who need this access more. Please be realistic here. Of course, we try to offer as many access as possible. And of course, once you have given access to these, you will maintain access until the challenge ends in this case.
That is very good. Thank you. Thank you so much, Dennis, for providing also these resources. And again, I see there are some questions. One we already answered. If it is possible to participate individually, yes, it is. You can participate as an individual or in a team. The most important, very important point is that you can participate only to one team or by yourself and nothing else. So only one participation for every person. And if startups can participate, yes, startups are welcome. Everyone is welcome. The important point is to have the point of the principal, so the responsible of the team. This case of the startup, they can decide who is the responsible, and the list of with the names of the people participating in such a way to check that people are not participating to more teams. And say that I see no other questions, but there is the possibility of posting questions. Now you saw also the platform. I want to ask all of you to come here on the stage. Also Fabrizio and Jacopo. Fabrizio and Jacopo are part of the people ready to answer if there are questions, and Albert as well. So thank you so much to everyone. Good luck to the participants. Very last point, when is the deadline? Deadline for submission is?
On the 30th of June, and please, you must have submitted your application latest 1 minute before midnight. So please take into account that it might take a few minutes to upload it, and we can't accept any manual submissions afterwards, so be on time.
Okay, okay. Thank you.
Maria, I
Yes.
may also add something, is that the winner will be invited to record a short video, a couple of minutes, and then it will be showcased at the GeoAI workshop at the for Good Summit on July 7th.
Yeah,
This will
yes.
increase your visibility for your innovative solution.
Yeah, yes, I was going exactly to say that. So I believe that this is another advantage, that beside the award, beside the visibility, because we will present the winner in one webinar like this one, but there will be also the possibility of presenting the solution, quickly presenting a solution at the AI for Good Global Summit, which is a very relevant event. It will be on 7th of July. So if your solution, if you have good ideas and you have the doubt that your solution can be the winning solution, keep 7th of July free for you, because there is the AI for Good Global Summit, and in the AI for Good Global Summit, there is a specific workshop on GeoAI, it's GeoAI for Sustainable Future. And so in this case, you will be invited to shortly present your solution. And say that, I believe that at this point, you have the economic award, you have visibility at the Valerio already spoke about the possibility, and Dennis about the possibility of joining or going to the PhilHub. Andrea said that there is the possibility of presenting at the AI for Good Global Summit. So a lot of rewarding points. Unfortunately, I can't participate, but I'm pushing my students in participating. And so good luck to everyone. Thank you. Thank you to all of you. And I believe that with this we can close.
Thank you, Maria. Thank you,
Thank you,
everyone.
Maria.
Ciao,
And good
ciao,
luck
ciao,
to
very
ciao.
much.
Thank you.
Bye.
Good luck.
Bye.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.